Okay, what we're being asked to do here is practice chopping in each direction. I'm going to do 3 of them. I'll let you do the other 3. The idea is that we have, we've actually looked at this before, something that looks like this. There's the plane. I'm graphing the plane by plotting its intercepts. So this is 6, this is 3, this is 2. What I'm going to do first is chop with respect to z first. So I'm going to draw a line that's parallel to the z-axis. It enters at the xy plane. It leaves at the plane z equals minus 2x minus 3y, and then continues on its merry way. So what I want to do here is I just want to do an integral, triple. I'm doing dz first. Since I'm doing dz first, all I really need to know about this point and this point is what z is as it enters and z is as it leaves. Well, z as it enters here is z equals 0. Z as it leaves is z equals 6 minus 2x minus 3y. So over here when I do the integral, the lower limit of integration is just 0. The upper limit of integration is just 6 minus 2x minus 3y, like that. Then there's supposed to be smushing going on. When I smush, I'm smushing from above because we're smushing the z values down to 0. And all we're going to see is the line 0 equals 6 minus 2x minus 3y. And we can actually do the intercepts there, although we already see them. There's 3. There's 2, like that. We can go like this. I can smush in either direction. I can chop in either direction. I guess I'm going to do parallel to the x-axis next. I'll let you do the other one. What I need to know about this is what x is as it enters. X is as it enters is x equals 0. X as it leaves is whatever x is here as it leaves. When I solve for x here, I'm going to get x is equal to 6 minus 3y over 2. And that's going to give me my next 2 limits of integration, as long as I say I did x next, like that. And x goes from 0 to 6 minus 3y over 2. We can smush again if we like. Or we can just say what's the location of the chops. I'm going to do location of the chops. They go from down to 0 to up to y equals 2. And we've done our first setup where we did z first. All right, let's do another setup. Where instead of doing z first, why don't we try doing x first? So it's the same region. This is still 6, this is still 3, this is still 2. I want to do x first. So I'm going to draw lines that are parallel to the x-axis. So they come from way back here. They hit the wall. They're now inside the region. And then they hit like the front of the tent, if you want to call that, and then they leave on its merry way. In order to do an integral here, what I need to know is integral, and I'm trying to do dx first. It's just what x is as it enters and what x is as it leaves. Well, the equation of the yz plane is x equals 0. So this is just x equals 0 back here. As it leaves, I need to know what x is as it leaves the plane. Well, I'm just going to look at our equation for the plane and solve for x. I'm going to get x is equal to 6 minus 3y minus z over 2. And those two things give me my limits of integration. This is going to be 0. This is going to be 6 minus 3y minus z over 2. Then there should be smushing. Now this time, we're smushing back to the yz plane because there can't be any x's anymore. We already used them up. So this is y, this is z, this is 6. I can see that just from the smushing. This is 2, goes back like this. We can now chop in either direction. I'm going to do y first. So I'm going to chop parallel to the y-axis. It enters here, it leaves here. I need to know what y is as it enters. Well, that's just y equals 0. That's very clear. What is it as it leaves? well, let's put the value down here. I need the equation of this. And where does the equation come from? I'm supposed to look at 6 minus 2x minus 3y, and we're smushing back to x equals 0. So when we smush, what we're going to get, right, is a z equals 6 minus 3y, and we're trying to solve for y. So y here is going to be 6 minus z, 6 minus z over 3, like that. And that's what y is right there. So we're chopping with respect to y next. With respect to y, and we see that the lower limit of integration is the y value as that chop enters the region. The upper limit of integration is what y is as it leaves that limit of integration, as it leaves the region, sorry, like that. And now to do dz, we could either smush again or just ask what's the location of the chops. Here I can just see that the location of the chops go down to 0 and up to 6, and we've at least done a chop where we chopped x first. I'm going to leave the other direction to you. Finally, we are going to chop with respect to y first. Same region, same roof. Let's see here, this is 6, this is 3, this is 2, and I want to chop parallel to the y-axis first. So I'm coming away from the left. It hits the region at the XZ plane, and now it's inside my little tetrahedron, and then it hits the edge of the tent, and then it leaves. I just need to know what y is as it enters and y is as it leaves. As it enters, it's y equals 0. The equation of the XZ plane is y equals 0. As it leaves, it's hitting the tent. I need to know what y is there. So I'm going to get y is 6 minus 2x minus z all over 3. So I can start setting up my integral. I'm going to go integral, integral, integral. We're doing dy first this time. And let's see, my lower limit of integration corresponds to when my chop enters the region. That's y equals 0. My upper limit of integration corresponds to the y value as my chop leaves the region. So I'm going to get 6 minus 2x minus z all over 3 like that. And we've taken care of that. The next thing we're doing is smushing. And if you want to know what we're really doing algebraically, that's a projection. It's a linear transformation, but we don't have to think that hard. We need to smush so that y disappears. If I smush so that y disappears, it should just be the XZ plane. This is 3, this is 6, and it just goes like this. And again, I'm going to chop parallel to the x-axis first, just avoiding the z. The z is going to be always the easy one in this case. I need to know what x is as it enters. Well, that's just 0. I need to know what x is as it leaves. Well, in order to do that, I need the equation of that line. And you can see that this line is what happens. No, I don't want that line. I want this line up here is what happens when we take the equation for the plane and plug in y equals 0. So I take the equation of the plane over here and plug in y equals 0 over here. I'm going to get z equals 6 minus 2x. I want to know what x is. So I'm going to get x is equal to 6 minus z over 2. That's the coordinate right there. That's going to give me my upper limits of integration and my lower limit of integration. For my next integral, we're doing with respect to x. My lower limit integration corresponds to the x coordinate when my chop enters the region, 0. The upper limit of integration corresponds to the x coordinate as my chop leaves the region. That's going to be 6 minus z over 2. The only thing that's left is z. I can either smush, or I can just see how high the chops are. The chops go as low as 0. The chops go as high as 6. And we've at least done a lot of the kinds of problems that you need to be able to see here.